All right, hello, integrated algebra students. Mr. Zacek here. Welcome to day 2 of Unit 13. And today we're going to be talking about measures of central tendency. And as you can read here in your notes, what we're looking at is how data clusters around a value. And we have 4 things that we look at when we're doing measures of central tendency. We've got the mean, which is the average. We have the median, which is the middle number. The mode, the number that occurs most often. And then the range, it's the difference from the highest to the lowest number. And one of the things that we're going to look at today is not only how do we find these, but how do we determine what is the appropriate way to measure? What are the strengths of some and the weaknesses of the other? So let's kind of jump right into it here. A lot of you, this will be familiar to. But the first thing that I like to do in this type of question is I want to order my numbers from least to greatest. So I go ahead and I'm looking at the values that I've got. Okay, 3, I got a 4, a 4, a 5, a 6, so 5, 6, and 8. And I just cross them out to let me know that I have put those values in order. So the first thing that we need to do is we need to find the mean. Well, when we're going to find the mean, we want to add all of them up. So 3 plus 4 plus 4 plus 5 plus 6 plus 8. And then we're going to divide that by the total number of values that we have. So we have 1, 2, 3, 4, 5, 6. So we're going to divide that by 6. So we do 3 plus 4 plus 4 plus 5 plus 6 plus 8 is 30. So we get 30 divided by 6. And the mean is going to be 5. 30 divided by 6 is 5. So, excuse me. Okay. So the mean equals 5. All right, the next one that we want to find is the median, and the median is the middle number. So if we count the total, we have 1, 2, 3, 4, 5, 6. So when we're going to find the um, median, we have to show how we're going to do that. Well, the middle number is going to be between. It's going to be somewhere between 4 and 5. See, if I count 6, 6 divided by 2 is 3. So halfway in is 3. Well, I get to 4 on this side and I get to 5 on this side. So we take those two numbers and we add them together and find the average of them. So 4 plus 5 divided by 2 is going to be 9 divided by 2, and that's going to be 4.5. All right, so again, median is the middle. All right, so we found the mean, it was 5, found the median, it was 4.5. Next, we're going to deal with the mode, and the mode is the one that occurs most often. Now, you can have more than one mode, but what do we see in here? Well, we have 4 and we have 4. Those occur twice, so our mode is 4, and I just like to circle that as a way of showing my work. And the last one is the range, and for the range, we're going to take the highest value, and we'll take the lowest value and subtract them. So our highest value is 8 minus 3. That means our range is equal to 5. All right, so mean is the average, median is the middle, mode is the most often, and range is the difference in those. All right, we'll do B here, and then we'll look into some aspects of when these are the best. Okay, B, the weight in pounds of Maria's 5 cats. Okay, 5 cats, that's a lot. So let's write them in order from least to greatest. 12, 12, okay, 12, 12, 14, 16, and 16. Okay, so let's just start it off here. I'm going to use a different color. Okay, so the mean. So for our mean, we're going to add those together. 12 plus 12 plus 14 plus 16 plus 16. And how many of them are there? 1, 2, 3, 4, 5. We're going to divide that by 5. So when we add all of those values in the numerator together, we get 70. Okay, this is 70 divided by 5. So the mean becomes 14. There's our mean. Now, for our median, now this time I count in, and if I count in 1, 2, 3 from the left, I end up at 14, and 1, 2, 3 from the right. So when you have an odd number of values, the median is just one value. And so there's our median, which is 14. So I want to show that, on my writing it out, I'm going to box it in. I like to use an arrow. That's kind of how I indicate my work. Then we have our mode. Our mode is the one that occurs most often. Well, here 12 occurs twice and 16 occurs twice. So I have two 12s and two 16s. So we're going to have 12 and 16. Sometimes with mode, what I'll do is like 12, okay, there's two 12s, 14, there's one, 16, there's two. That's another way you can show your work for mode, is just to write it out like that. So 12 and 16. All right, and then range, the last bit that we have is the greatest minus the least, which is 4. So the range in this example is 4. All right, and then C, there's one that you could practice on your own, but we're not going to do that right now. I want to look at some scenarios where we can determine which one is best. Okay, a store owner keeps a tally of the sizes of suits purchased in her store. Which measure of central tendency should the store owner use to describe the average suit size? Okay, well, you wouldn't want to use the mode or the range. Those two would kind of be out. Mode would be the one that most people buy, but it's not necessarily the average. Range, we're not looking for the range in suit sizes. So here we're going to look, it's either going to be, the middle, which would be the median, or the mean. And I think you could, kind of make an argument for either one. I would probably say the mean would be the best because it's going to give you, again, the average of what we had. Now, as we look at B, a tally was made of the number of times each color crayon was used by a kindergarten class. Which measure of central tendency should the teacher use to determine which color is the favorite color? Well, this one's going to be who likes the most, and so this is definitely the mode, because this is going to be the most liked, the one that occurs the most. That's definitely an instance of mode. And then C, the science test grades are posted. The class did very well. All students taking the test scored over 75. Unfortunately, 4 students were absent for the test, and the computer listed their scores as 0 until the test is taken. Assuming that no score repeated more times than the zeros, what measure of central tendency would most likely give the best representation of this data? Well, in this instance, the mean is going to be brought low because you're averaging in zeros. And listen, whenever you're averaging in zeros, they bring your grade way down. Okay, that's when you don't do an assignment, or that really brings your grade down. But the median, all right, that is the one not affected by what are called outliers. And whenever you have like a really low value or a really high value, those are going to skew the mean, okay? But the median, the middle, is still going to be there, okay? So not affected by outliers. So let's just write this down. The mean is affected by outliers. And when we say outliers, we're talking about very high or low values. Okay, so there's an example of some different types of, places where we would use the mode, where we would use the median, and where we would use the mean. Okay, now number 2, very popular type of question And I want to make sure that we go through it so you can see how the setup is and sometimes where the points of confusion are. The value of 11 houses on Washington Street are shown in the table. And so what we have to realize here is that together the total is 11, okay, houses. But 5 of them are priced at 175,000. So when we go to find the mean, what we have to do here is we've got 1 at 100,000. But we have 5 at 175,000. And we have 4 at 200,000. And then we have 1 that's, pretty pricey up at 700,000. Okay, all of them are actually kind of pricey. And then the total is 11. Okay, so often a common mistake is people don't put in 5 175s. They only do that once, and that would really change our data. So we can calculate what this is going to come out to, and we have 100,000 plus 5 times 175,000 plus 4 times 200,000 um, plus 700,000. I'm just entering this into my calculator. And that comes out to be 2,475,000. Okay, so I can squeeze this in. 2,475,000 divided by 11 is, so the mean is 225,000. Okay. Now, find the median of these homes. Okay, well, to find the median, I like to write it out to find the median. So what I'm going to do is just shorthand it. I'm just going to write 100,000 as 100, and then I'll change that. And then I've got 175, 175, 3, 4 175s, 5 175. Then I've got 200 4 times, 3, 4, 200, and then 700. We got one of those. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So halfway in. So we come in 1 from this side, 1 from this side, 2 from this side, 2 from this side, 3 from this side, 3 from this side, 4, 4, 5, 5. That puts us back here. There's our middle. So our median is 175,000. Okay. Now, why doing that data? C. State which measure of central tendency, the mean or the median, best represents the value of these 11 houses. Okay, so let's go back and look at our data. The mean is 225,000. The median is 175. Well, if we look at the mean, 225, there's only one house that's more than 225. Every other one is less than 225. So what that means is that mean value was really affected by this 700,000. That's the outlier that we were talking about before. So a better one would be the median, because that's kind of in the middle. And again, it's not affected by the um, outlier of 700,000. And when you are looking at the data for household prices, if you're in real estate, they're always going to use the median. Okay, so in real estate, this isn't necessarily justifying the reason, but just for your information, they use median. Generally, if you're going to read a news article about home prices in the area, they're going to use median, okay? Because somebody could move into an area and maybe their house is worth 3 million, and again, that would really affect the mean, but it's probably not an accurate representation of what's happening there. Okay, so you have a couple other ones that you can look at here on your own, but I want to jump to the next page because these ones have a little bit more of a challenge to them, a little bit more algebra, and we see these often, and you need to know how to do these. Okay, so this is the next page of your notes. Um, when Paula went bowling, she scored a 108, a 128 in her first two games. What must she score in a third game to have an average score of 122? Okay, let's start with this. Let's let x equal her third game score. So we're talking about the mean, so we have to add these together. Her first game she gets 108. Her second game she gets 128. Her third game we don't know the score. Now, the mean, those divided by 3, we want it to equal 128. Okay. So, what we can do in this instance is we can use the cross product property. We can multiply these values together and we can set it equal to those. And the nice thing is when you multiply by 1, it doesn't change the value. So 108 plus 128 plus x equals 3 times 128. So now we want to combine like terms, and we're going to get 236 plus x equals, and then we're going to do 3 times 128. So 3 times 128 is 384. And then we're going to subtract 236. And so when we subtract 384 minus 236, we come out with 148. So she's got to really have a great third game to get that 148. And you could go back in and plug that in and check it out, and you'll find that it's going to work out. All right, so let's try a couple more here. I want to do number 2, and then I'm going to jump down and do number 4. On its first 5 math tests, Caleb received the following scores: 80, 88, 91, 61, and 79. What test score must Caleb earn on his 6 tests so that his average for all will be an 83? So here again, let's do a let statement. Let's let x equal the score on the 6th test. Okay. So we have 80 plus 88 plus 91 plus 61 plus 79 plus x. Now, how many of those are there? 1, 2, 3, 4, 5, 6. So divided by 6, we want the average to come out to be 83. So now we're going to cross product property here. And we're going to get 80 plus 88 plus 91 plus 61 plus 79 plus x equals 6 times 83. So when we combine our like terms, 80 plus 88 plus 91 plus 61 plus 79 is 399 plus x, and then 6 times 83, 498. So when you subtract 399, okay, 498 minus 399 comes out to be 99. So he's got to get a great grade on that last test in order to reach that average. So hopefully you see what we have to do there. You set it up, define it with your let statement. Okay, use your cross product property, combine like terms, go ahead and solve. All right, now our last one for the day is going to be number 4. Find, in terms of x, the mean of 3x minus 5, 5x plus 8, and 4x plus 7. Okay, so what we have here is this is the first term, this is the second term, and this is the third term. So together we have 3 terms. So our mean is going to be 3x minus 5 plus, I'll just put it in parentheses to separate, 5x plus 8 plus 4x plus 7 divided by 3. Now, let's combine like terms. So I'll get my highlighter here just to help us with this. I got a 3x, 5x, and a 4x. And then we got minus 5. Ooh, I don't like that color. Doesn't show up too good. Let's try this. We got minus 5, plus 8, plus 7. Okay. Now, so 3x plus 5x, 8x, plus 4x is 12x. Okay, negative 5 plus 8 is 3, plus 7 is plus 10. Okay, divided by 3. So, sometimes we want to see if you can simplify. The top has a GCF of 2, so it would be 2, and then we'd be left with 6x plus 5. Okay, 3. Does that go into it? No, it doesn't. 3 doesn't go into 2. So either way, um, looking like we got our answer there. So mean, median, and mode. Hopefully this is something you're feeling very confident in. Okay, very popular thing for in algebra that we need to be able to answer well, and hopefully you've seen some of the different types of things that you will see as a part of this. Okay, good luck. Thanks. Bye.